Hey, Problem Stats, Mr. Monahan here. This is lesson 2.1b for experimental probability. Get your note packet out, write down the goal on the front, and then flip to the page that's the appropriate page for today's lesson. The goal is I will be able to understand the difference between theoretical and experimental probability and be able to find both kinds of probabilities as well. First thing I want you to do is review from yesterday. This one says a bag contains 4 red marbles, 16 yellow, 5 purple, 6 blue, and 10 green. I want you to see if you can pause the video and answer each of these 5 questions. Go ahead and give that a shot right now. Click pause and then click play when you're ready. So you should have tried these. When you're looking at the probability of each of these, you need to know how many total marbles are in this bunch. So we have 4 red, 16 marbles. That makes 20, 25, 35, 41 marbles, it looks like, in this situation. So what we're going to do is we're going to start to look at what number needs to go on the bottom of each of these. So my answers will be all in terms of the fraction. There are 41 possible marbles in our list. And if there are 10 green ones, then our answer would be 10 out of 41. The probability that you get something that's not green, anything but green, that would be the rest of the marbles. So if there's 10 green marbles, there's 31 marbles that are not green. So you can just do 41 minus 10, or you could do 4 plus 16 plus 5 plus 6 and get 31 that way. Red or yellow, we're going to add the red plus the yellow, which is 4 and 16, or 20 out of 41. Getting one that's purple and blue, bit of a trick question. If you pick one marble, there are 0 ways for you to get a one marble that is both purple and blue. And then not purple is all the ones that are any other color except for purple. So there are 5 purples, which means there are 41 minus 5, or 36 purples. You can go and you can get a decimal for those if you wish. Today, we're going to talk about this difference. Theoretical probability is what we just did with the marbles. It's also what we talked about yesterday. What we said is you want to divide, what do you want, divided by what you have. It's the probability that's supposed to happen. It's not what necessarily happens, and that's what we're going to talk about today. So favorable outcomes go on top, total outcomes go on the bottom. So we got to be able to figure out how many ways something can happen. The new one today is experimental. So this is what actually does happen. So experimental is the probability that actually does happen when you actually do the experiment. So this is not theoretical anymore. This is what actually happened or happens. So these two probabilities can and usually will be a different number. So experimental probability is what actually happens. Theoretical is more of a prediction. Most of the time we're going to do theoretical, but experimental it has its place too in some things that we will have you look at. So if you're looking at a spinner, so I think I have a picture of a spinner up that I can pull up on the screen with a red, a yellow, orange, red, orange, green, and blue for our options. Okay, so instead of yellow, we'll just say that yellow is orange for what we're looking at in our table. But we have 4 spaces in our spinner that are equally spaced out. So that means each one theoretically has an equal chance to pop up, which means each one has a 1/4 or a 25% chance of popping up. Okay. So experimentally, that's a little bit different. So let's say we do this 12 times. I will bring up my little simulator here, and we're going to spin this spinner 12 times, and we're going to see what actually happens. I'm not going to have us watch all of it, but that was 1 spin, 2 spins. We're going to skip all the way to 12. So, wow, I have a very big difference in mine. I had 6 blues pop up and then 2 of everything else. So that'll be easy to remember. So if I go back over and we can record these experimentally, blue, I had 6 out of 12, which is 50%. Okay, remember that these were all 25% theoretically. Okay, so 50% of my spins ended up being blue. The rest of them had 2 out of 12, which is about 16.7% for each of these. So in my experiment, I thought that I would get about 4 of each, right? 25%. But I got way more blue than anything else. So my red, yellow, and green spinners actually came up fewer times than I would have predicted, and my blue came up more times than I would have predicted. Okay, so it should have been, so you can see in here, what we're looking at, theoretical, should have been 25% for all of them, but we really did not end up having that. And we'll talk about what issues that brings up in a little while. Here's an example of an experimental. Sally makes 5 out of 45 free throws she took in practice. In her next game, what is the probability she makes the first free throw she takes? This is really experimental probability because we're basing this off of something that has happened previously. It's not, this is not something that we are looking at as in theory. This is looking at, well, here's what's happened before. What's the probability that we make that next free throw? So the probability of making that free throw is 5 out of 45, which is also 1/9. So 1/9 would be a good answer, or 0.111, or 11.1%. So we're looking at stuff that's happened in the past. She's actually gone and tried these free throws, and she only makes about 11% of them. Okay. Okay, when we're rolling any given number on a die, a 6-sided die, everything has a 1 out of 6 chance at popping up. We call the roll of a dice a random event. These are all 16.7%, by the way. Okay, all the way up. So that is a theoretical. We haven't actually rolled any dice. This is just a theoretical number. This is just saying, in theory, if you roll a dice, everything has an equal shot at coming up. So we call it a random event. Since all outcomes have equal probability or an equal chance of popping up. When that is true, it's called a random event. So on a normal day, if you weren't watching this online, I would have you roll some dice. We're going to roll some together. I have another simulator that I'll pop up. Let's look at it with 12, and then maybe I'll do it out of a little bit more for the class part. Excuse me. So if I get my spinner back up, my other tab is a dice roll. So we should be ready to go right here. And then they're going to go ahead and they're going to graph our results too. So if we're rolling 1 dice, we're going to go 12 times. So I just made it roll 10 times. And then I'll go 11 and 12. So there's my results from 12 rolls. So I got 4 1s, 3 2s, 1 3, 1 4, and 3 5s. So 4 3, 1 1 3, and I actually didn't have any 6s. Didn't get any 6s. So it was 4 3, 1 1, and what was my extra number? Another 3. I had 0 6s. So experimental probability, this was 4 out of 12. Okay, or it was 33.3% of the time, I got a 1. But if you look up here, I'm only supposed to get a 1 16.7% of the time. So something's not really working out here. 3 out of 12, that's 1/4. I got a 2 25% of the time when it was supposed to be 16. 1 out of 12. With 1 out of 12, I lost my train of thought there. Looking at the percentage, it's supposed to be 16.7%, but this is about 8.3%. It's about half of that 16.7. And so 3 out of 12, again, this was 25%. And then my last one, 0 out of 12, is 0%. So the numbers are a lot different than what I think should have happened with the 16.7% over and over and over again. But that's just kind of the way it goes sometimes. What if I would have done 112 rolls? Rolls. I can go ahead and do that really quick. I can do 100 more right here. And now you start to see it's evening out a little bit. We'll talk about that shortly here. So you also have this class table in your notes. I'm going to put those results out of 112 just so you have something to work off. On the homework, they're going to ask you questions about our class results. So I'm going to give you those numbers again. With my simulator, you're going to use, we got the number 1 17 out of 112 times, then it was 19, 15, 22, 25, 14. So just look at those out of 112, and you'll see when you get to the homework, they're going to ask you about that. They're going to have you look at answering some questions. So you need some data. Use this for the homework. Okay, use on homework. So the last thing I want to show you then today is this kind of graph here, and I'll help you try to understand it. So this is proportion of heads, so flipping a coin, as the number of times I've tossed it increase. So on the first toss, I got heads, it looks like. So that would mean my experimental probability was 100%. So 100% probability that I get heads. But then I flip a couple more times. By the time I'm at close to 5, you can see my probability has switched to be I got tails more than heads. And you see kind of this pattern where it's really jumping up and down. But when the number starts to get big, look where my probability is at. We know theoretically the probability of getting a heads is 50%. I'm starting to even out along this line that would be 50%. As it's up to 10,000 or 100,000 or 1,000,000, my line is going to be so close to that 50% line, you're going to barely be able to tell that it's even a different line. This is called the law of large numbers. The law of large numbers. And here's what it says. If an event with numerical outcomes is repeated over and over and over again, the average of the outcomes approaches the expected theoretical probability. So what that means is if you flip a coin enough times, you're going to get very, very, very close to 50% tails and 50% heads. Just over time, these random events even out. If you did our spinner with the 4 equal spaces, if you did that 1,000,000 times, it would be really, really close to 25% for each space. Same with the other example with rolling the dice. We only did 12 examples, and you saw how far off our percentages were, right? After 12, we had nowhere close to 16%. But even after 112, we were a little bit closer. So if we rolled the dice 1,000,000 times, we'd be really, really close to 16.7% for each. Okay, so that's just an idea that I might ask you about on the homework. So that's it for today. So theoretical and experimental probability are different because theoretical, we're not actually doing the action. Experimental, you're looking at actually flipping that coin or actually rolling that die or whatever it might be. So they are a little bit different. Try some of the homework problems. Again, you need part of the video today to do the homework. So I pointed that part out to you. Have a great day. Let us know what questions you have.